Dear student, in our previous class we learned about these types of enzymes and what is enzymes. These things we learned. In today's class, we'll learn about uh, process of enzyme inhibition. So, how one enzyme can be inhibited or how one enzyme stop working, that is called mechanism of inhibition. That there are different types of inhibitory mechanisms for one enzyme, that is called enzyme inhibition, and several factors can limit enzyme activity levels through different mechanism as follows. First one is competitive inhibitors. This inhibitor molecule blocks the active site so that the substrate has to compete with the inhibitor to attach to the enzyme. That is called competitive inhibitor. Non-competitive inhibitor means this molecule binds to an enzyme somewhere other than the active site and reduces how effectively it works. An uncompetitive inhibitor means this inhibitor binds to the enzyme and the substrate. The products leave the active site less easily, which slows down the reaction. Then irreversible inhibitor means this is an irreversible inhibitor which binds to an enzyme and permanently inactivates it. Then some factors are there which regulate the activity of enzyme. Such factors are one of such factors are enzymes and substrates. The concentration of enzymes or concentration of substrate also uh, affect the enzyme activity. If the substrate concentration is increasing, then the rate of reaction increase to up to one position, uh, up to up to up to one up to one level. Then if after that portion the rate of reaction uh, becomes constant, and from that position the reaction does not increases. As that means if the concentration of substrate is also increasing, the rate of reaction will not go to the top level. That means it stiffs this way. So next one is effect of temperature. If we see the effect of temperature in enzyme activity, then we see from low temperature to one level of temperature, the rate of reaction increases. But after that, if the temperature increase again, then the enzyme activity decreases. That means first it will increase to a point, then it decreases, and this the highest the temperature at which the rate of reaction is highest, then that temperature is termed as optimum temperature. That means at higher temperature also that enzyme does not work, at lower temperature also the enzyme does not work. Then effect of pH. pH also affect the rate of reaction. At temperature, at lower pH, the rate of reaction will be minimum, and as the pH level increases, the rate of reaction increases, but after a specific point the rate of reaction start decreasing although the pH is increasing. That means like the temperature at a certain point the temperature is the pH one pH is there at which the rate of reaction is highest, and that pH is termed as the optimum pH. And there is these two terms you must have to remember. One is optimum pH and the another is optimum uh, temperature. So these are the factors affecting enzyme activity. For today, the I will learn another thing, that is an effect of inhibitors in rate of reactions. If the no inhibition is there, this will be the graph to show the normal enzyme activity. If there is competitive inhibitor and non-competitive inhibitor, as I have defined, and you also know in our previous slides. So if the enzyme is inhibited by competitive inhibitor, then the rate of reaction will be this graph will indicate the rate of reaction, and if the inhibitor is non-competitive inhibitor, then the rate of reaction will be this represent the rate of this graph represent the rate of reaction for when non-competitive inhibitor is present along with the enzyme. So this is the basic thing in studying enzyme activity, enzyme factors affecting enzyme activity, and types of enzymes, and enzyme inhibition system. These are the things. In later classes, in other classes, we'll learn about mechanism of enzyme action, then types of enzymes, enzyme kinetics. There are some equation to study the enzyme kinetics, that is Michaelis Menten equation is there, line Weber equation is there, and this equation will definitely you'll be definitely show you the how the enzyme kinetics is controlled by this type of mechanism or this type of equation. So thank you. In next class we'll meet you and we'll learn about these things.